I agree with what you're saying, though. It's talking to people all over the world. Central
America. Okay, here we are. We're live. It's Wednesday today, and it's the 3 to 4 block. And we're talking about business intelligence, that is ThinkTech Talks, the emergence of the bare metal cloud, which is really, to me, a mystery, but I'm going to find out from Bruce Templeton. He's the CEO of NephoScale. And NephoScale, Nepho means cloud, so that's a great choice of words. Welcome to the show, Bruce.
Thank you very much.
Thank you very much.
Bruce is joining us from California by Skype. We love Skype because Skype is, what do you want to call it? It's completely transparent for the world, so you can. We have talked to everybody, everywhere on Skype. You know, I thought a few months ago that if we wanted to talk to India, you know, there'd be issues. Nah. So you could be in California, you could be in India. It doesn't make any difference. The only thing is you're on Skype.
It's great. Yeah, it's great.
Anyway, Bruce, you're a technology guy, which is really our middle name. And I'd like to get a handle on what you're doing, and I certainly appreciate your flexibility in working with us on the schedule. So tell us a little about yourself. Tell us how you got into technology, and ultimately how you got into NephoScale.
Sure. So we are located in Silicon Valley. In fact, I think the whole team is born and bred here. Although of different nationalities, ethnic backgrounds, right? That's typical of this area. So our CTO, Telemachus Liu, he picked a Greek first name. His real name is Min Liu by birth, so he's part Vietnamese, part Chinese.
I love it.
Yeah, so we're all over the map. We have an Indian person with us. So, but I grew up here. My parents met at Stanford University, of all places. My father's an engineer, and so I got into technology and ended up joining a company named Foundry Networks in the late 1990s. It went public, and we competed against Cisco Systems, selling switches and routers and whatnot. And it was a successful IPO, and I took money from that, and I bought a company called Silicon Valley Web Hosting in 2005. And that was started by a gentleman who is a software programmer at Stanford Linear Accelerator, the particle accelerator there. So he ended up leaving Stanford in 2000 and quitting his day job, if you will, and ran Silicon Valley Web Hosting. He found in 2005 that he missed some of the work back at Stanford, and he didn't really like managing employees, is really what it came down to. So he's a real techie at heart. And I ended up buying the company from him. And I bought two more hosting companies soon after that, all local hosting companies to Silicon Valley, and rolled them into the Silicon Valley Web Hosting name. And Telemachus Liu was a good friend of mine who was one of my original customers at Foundry Networks, of all things, so we'd stayed in touch. And he had gone on to a company called GoGrid in San Francisco. It's some of your viewers might be familiar with them, but they're also a cloud computing company. So our core engineering team, our CTO, chief architect, and director of engineering all built the GoGrid cloud platform. So they started in 2005. They built 3 clouds while there. The first 2 didn't work in such early days. So you could say we're really pioneers in this space. And the one that GoGrid has today is the 3rd one that our team built. This is really their 4th one. So in a sense, this is their next generation cloud. So they learned a lot.
Can you stop there for a moment, Bruce, and just tell us what a cloud is in the context you're describing?
That's a very good question. So Salesforce.com liked to use the term back in 2005, I think it was. They started doing marketing around them being a cloud service. Well, they were doing software as a service back in the late 90s when they first got started. Nothing changed. All it changed was the marketing. So what is cloud? Well, to us, cloud is the management of infrastructure using software, being able to run the data center with software, and actually being able to use an API to even program your application to work with the software, with the architecture, or with the infrastructure. So you should be able to have your software make calls to the data center and automatically provision servers and storage and network the way you need it to automatically compensate for what's needed in your application. Now that's an advanced use of cloud infrastructure. We do have an API, we have customers doing this. But so many others just go into a credit card and go into our portal and they click their way through and they have servers up in minutes. So that, there's the advanced users that use the API, and then there's the more typical user who just goes in and uses the GUI and point and clicks their way through after entering a credit card.
So forgive me this, but I had the impression that a cloud involved servers that were completely fungible. It didn't matter where the server was. It formed this kind of virtual system. It could be anywhere, all linked together by software, and that made it different because it was unified only by software, and in fact the physical location of the server was unimportant. Tell me whether that's true and how it works.
Sure, there's a lot of confusion around cloud because of what Salesforce.com and many other companies have done, where they've tried to make you think that what they already offered previously over the internet, which is subscription-based service, where you put in a credit card, and instead of getting a CD-ROM sent to your house like in the old days, in a box where you load it into your computer, you now didn't get any software. They ran it on their servers, and you just put in a credit card and then used the service. And in that situation, it's true. You don't know where the server's located, and nor do you care. Right? But that's really just subscription-based software as a service. But now anything internet is cloud, which is rather frustrating for the people that, like us, started developing and releasing products in 2006 and 2008 when Amazon, for instance, came out with Amazon Web Services. That was cloud. That was the only thing that was not possible prior to that.
What was the magic disruptive feature of Amazon's cloud?
And it wasn't just Amazon. I mean, I'll run you through a little story here, and I'll start. I went and spoke with to a group of Chinese investors and executives recently, talking about the history of the internet. And very briefly, you had chip design with Texas Instruments and Intel in the late 70s, and then you had Apple Computer with the Macintosh, and then you had networking come along, where 3Com, Robert Metcalfe out of the Stanford Research Park, invented Ethernet. And Ethernet came along. Then you had Cisco with the Ethernet, and you had Microsoft with the desktop. So now you have the personal computer, you have the chips, you have the desktop software, you have the network. Oh, it's starting to come together, right? Still, the internet was not fully public until 1995, when the government completely got out of it. It started in the early 90s, but it wasn't until 95 when it really started going full public. And that's when Amazon was launched. So here we go, it's 5 books online. So the first e-commerce. And then it was in the late 90s when you had companies like Salesforce.com starting to offer software as a service. But in a sense, it was all just e-commerce is using your credit card to buy something over the internet. It was SaaS, which is using your credit card to consume software and not have a box shipped to your house. But it wasn't true cloud until around 2006. So VMware is a company that really helped pioneer virtualization. It was really started with zone technology out of Sun in the late 90s, but it was really VMware that made virtualization very popular. And they took that to the enterprise, and people started virtualizing their servers. And then open source like Xen and KVM started coming out. These are called hypervisors, which VMware has ESXi. Now Microsoft has Hyper-V. So these are all hypervisors that are software that run on a bare metal server, if you will, and allow you to chop that thing up into a bunch of little virtual servers. Now it creates overhead and makes things a little bit slower, but it allows you to efficiently use the server where you can load Windows and Linux operating systems in these little server buckets and run lots of servers on one machine. Pretty slick. But it wasn't until software-defined networking, the hypervisor technology became further developed. Storage technology started coming out, like OpenStack Swift, where you could start to, and APIs, where you could start to tie all this together and make a data center exposed via a GUI or an API. So it's a little bit like Mark Andreessen with Andreessen Horowitz, very famous. He started Netscape, made the Mosaic browser, very well-known person in Silicon Valley.
I remember it well.
Yeah, and he says software is eating the world. That was a famous comment he made several years ago, right? And the idea is everything can be run by software now. And, you know, even Apple with the iWatch coming out, right, yesterday, and exciting stuff. But software is driving, even though Apple makes hardware, it's really the software that makes the payment system work, or iTunes, or iCloud. And so it's very interesting how, you know, we believe the cloud is anything that is on demand, to put in a credit card and get going on your own, self-provision, so you should go self-provision it, and for infrastructure, it has to be programmatically controlled. There needs to be an API that you can tie into and integrate with, so you can automate processes in conjunction with your application that you're developing. So almost all the web startups these days that have some kind of web scale application, whether it be social media, e-commerce, digital marketing, big data, you know, most of them are taking the API and they have sophisticated programmers on staff that are tying that into the cloud that they work with.
So if I'm a developer, whether it be you know, iPhone app developer or an enterprise level developer, I'm going to use the cloud in order to make my stuff. Is that right? Is that what's happening?
Yeah. Yeah, I mean, you might start running some code on your laptop, but after a while, you're going to want something more robust, especially if you want to work with other, you know, you hire two other people, you have two other co-founders, you're all developers, you all want to get in and mess around with the code. You don't want it on each other's laptops, so you put it, quote-unquote, in the cloud. You quote-unquote, spin up a server, you self-provision a server. So you can, nowadays, what you can do is you can be in a Starbucks. You can have a product like a NetSuite or some accounting software, Intuit or something. You can do your payroll through the internet. You can have marketing stuff going on. You can have one person says, I'll handle the IT. And you all have laptops, and you're sitting in a coffee shop, and you have internet access. And nowadays, instead of going to a data center and building racks and buying equipment, you just put in a credit card, and you spin up these servers, and you load some applications, and tie your API into it, and, you know, turn towards your co-founders and say, done. I'm now up in two continents. We got this going. The database is set up. Everything's ready to go. Start going into development. That's just amazing.
It is amazing. And all you need is a laptop and a credit card to get onto the server.
Yes. To create servers. You literally are provisioning. So the virtualization is what Amazon and Google and many of these other, Microsoft, Azure, a lot of our competitors, they only offer virtual. Almost every single provider out there offers virtual servers only. Now, we don't believe that virtual servers are necessarily cloud. These big companies are trying to convince you for their own reasons, meaning VMware makes ESXi hypervisor. Do you think they want to give you a server without a hypervisor? That would eliminate the reason for being in business. Microsoft makes Hyper-V. They have their own vested interest for keeping you from doing that. And then Amazon and Google have very highly automated data center environments where they want to fit you into a box and make you do it their way. Well, that's not necessarily going to work for some companies. So there's also overhead with the servers. So virtualization is great when you want a little piece of a server. But what happens when you know you're doing big data, you're doing some kind of number crunching, data mining? There's all kinds of applications out there where you can be crunching lots of data.
More and more.
More and more. So let's say you know you're going to be using that computer day and night. You can tap it out, and then you'll create another one, and you'll be able to use all the resources on that one. Why would you want to have a virtual server where you're competing for the network port with somebody else? You're competing for access to the motherboard bus. You're competing for, now you've got overhead with the hypervisor of 15 to 20% overhead. Why do that? It's a waste of money, and you're not going to get the performance. So this is where bare metal servers come in, is allowing a customer to use the API or the GUI to quote-unquote spin up a bare metal server with nothing on it. Literally, it's a 1U or a 2U server in a rack, and you are the only one on it. It's more secure, it performs better, right?
Hold a second. We're going to take a short break.
Yeah.
Because now we've hit the bare metal part of our show.
Yes.
And now we're going to make sure they understand about that. This is the big time. Okay. That's Bruce Templeton, CEO of NephoScale in Silicon Valley, California. We're doing business intelligence and the emergence of the bare metal cloud. We'll be right back after this very short break.
Okay.
Hello, I'm Martin Despang, and I'm the host together with the one and only Ali Amashta, and our show is called Urban Transcendence. And Urban Transcendence is about identifying where we have a unique situation of a vibrant city in one of the most beautiful natural environments. So how these two can coincide, sometimes conflict, how they could find reciprocity in the 21st century is what we're excited about. And we're planning on bringing in a diverse body of guests, both from the arts and the science, and the established and the wise and the emerging generation. So hope you will join us. We'll always be on Thursdays from 1 to 2 p.m.
Hey, this is the way we'll all have to go. We're back. We're live. I'm Jay Fidell. This is ThinkTech Talks, and today business intelligence and the emergence of the bare metal cloud with Bruce Templeton, who is the CEO of NephoScale, and the idea is, you know, he can make your head hurt, but we're going to get by that. We're going to learn today about bare metal clouds. So just before the break, we started to actually, you know, hit bare metal. So what's the difference between the virtual server and the bare metal server? So we all should know.
Well, so I want to be clear here is that we support both. So we're not saying bare metal clouds are the only way to go. And there are a couple companies out there that are saying that they'll just give you bare metal servers. One of the challenges is the virtual servers, as I mentioned earlier, are little servers where you slice up a piece of a bigger server. So you have this hypervisor, that's the management software that runs all that. VMware is one of the companies that pioneered that. And they, you know, these hypervisors allow you to break it up. So we allow customers, when they provision a server, it actually automatically carves out a piece of that server based on the server plan that they chose out of our portal. So it's a slice of a bare metal.
You know, I remember years ago when I was programming websites, and I went to one of these server companies. You could get a slice, so to speak. You could have a piece of a server, and you shared it with a lot of other customers. Or if you were ready for the big time, you would rent your own server. It would be only yours, dedicated to you. Is that the same thing as a bare metal server?
It's different. So what you're talking about is shared hosting, much like GoDaddy kind of made that famous.
Yeah.
And shared hosting is where you would share another server with a bunch of other users. But here's the difference, is you cannot go in and create your own server within that server.
Okay.
You can't say, I want Windows, or I want CentOS, or Debian, or one of these other Linux operating system flavors, Red Hat. You can't do that. They load an operating system on it. They put a thing called cPanel or one of these other software managers on there, and then you get little slices of it. So it's completely different, and not quite as secure, and you don't get as much control over what you do. They also, with modern virtualization, they'll carve out CPU and RAM for you. So you'll be guaranteed a certain level of performance. Where you did not get that on the shared servers, you would just have to call up your hosting company and say, the performance is horrible. And they would move you on to another one that has fewer people on it. Because you were never guaranteed a slice of it. So the virtualization is a completely different thing. It's for enterprise use, right? It's enterprise grade, where you can pick your operating system, you can spin the thing up. And the other thing about it is you can compile code on it. And it's an actual server. The shared systems wouldn't allow you to compile code. You could just run your website. So it's a much different thing. But so with the virtual server, our lowest cost virtual server has SSD drive running it, has 10 gigabit per second connectivity to the network, very fast, but it's as low as $3.89 a month. It's only half a gig of RAM, one core. But we cannot give you a dedicated server for $3.89 a month.
No. You'd never be able to pay for the server.
No. So our most expensive virtual server is about $400 or $500 a month. Could be 32 gigs of RAM and 16 cores, right? Very powerful.
What's the space there? Is it a core?
I think it's about 600 gigs of SSD. You'd have to go to our website and look at it.
Okay. You have a menu there where you can pick from in a matrix.
Yeah.
The matrix.
All the pricing's on our website. But So our lowest cost dedicated bare metal server is $139 a month. So the question is, what is the best deal in between $139 and $400? Meaning the most expensive virtual and the cheapest dedicated. There's overlap in there. You could choose one or the other. I would say for processing data, the best value is going to be the dedicated server. That's why we don't see as many of the large virtuals created on our platform, because people usually opt for a dedicated at that point. So that works? I can't hear you. Oh, so bare metal then is with no hypervisor on it. So there's no other, it's a single tenant, there's no other user on that server. It has no hypervisor, so you're getting rid of the 15 to 20% overhead, and you get more performance out of it. You just cannot match the performance.
Okay, so is that closer to the $100 model or the $400 model?
Well, so our dedicated servers are available in 5-10 minutes, just like our virtuals. You can even use the same base images. So it's very easy to, quote unquote, spin one up. And then they're on the same network with your virtual, so you get the best of both worlds. So that is one of the challenges why some companies have bare metal only, and some companies have virtual only, because we built software-defined networking technology that allows us to join them together in an automatic way. So that's a big part of our value add, and that's the big challenge for anybody who's trying to create on-demand virtual and on-demand bare metal dedicated on the same network automatically for the client.
So you use the term spin them up, and I guess that means when I'm sitting there in Starbucks with my credit card and my laptop, I can actually establish a server in 5 or 10 minutes.
That's correct. I mean, I think I sent you some screenshots on that where it shows where our drop-down list, and you choose your server type, you choose your operating system, you hit go, and it's up in 5 minutes.
Okay, we got those shots. So why don't we take a few minutes and look at them, and you can give us a running account of what they mean. Okay, let's put them on the screen. Can you see what we have on the screen? Maybe not, but we're going to bring them on the screen now.
So I can see your monitor to the left. I just muted my screen, but I have a...
We don't have them available right now. Sorry, we don't have them available. So, take us through it anyway. What has to happen?
So it's literally a drop-down list that would pop up in our portal, and you'd be able to choose dedicated or virtual, and then once you get into the dedicated virtual areas, you can choose which type of server you want, and then you choose the operating system, Windows, Linux, whatever type of Linux you want, 64-bit, 32-bit, your choice, hit go, and you're set up. In 5 minutes. It's up. So
okay, then now when you just so a guy like me can understand. So now it's up, and I've gone through all of those steps, and I suppose once you've done it once, it's even faster the next time. Then what do I have to do to get my system going? I have to program on my laptop, but my laptop is actually on my server, and now I can do big data. I can establish databases and so forth.
Well, it all depends what you're doing. If you're just doing development work and compiling code, that's one thing. But if you want to actually put up a website, typically some type of web interface that you'd be exposing to the public, whether it be, we mentioned before, whether it be social media or some kind of big data analysis engine or e-commerce, there's many different things you can do out there that expose your product to the internet and make it usable for people. That's a production environment. You're going to have all kinds of applications loaded, and some servers might be allocated as web servers, wanting web software, web services software. Another one might be an application server. Another one might be a database server. You might have clusters of different types of databases. You could be running Oracle or MySQL relational databases, or in-memory databases like SAP HANA, or you could be running NoSQL or Hadoop. So there's Mongo, Hadoop, lots of different types of NoSQL.
So I go on the server that I've just created. I spun up my server, and I open a browser and I download whatever software I want into that server. Now I'm using all of that software on the server to build my program, to build whatever I'm doing. and I'm controlling it from my laptop in Starbucks.
Yeah, basically, yeah, you'd FTP, applications to it. You might even go to a vendor's website like Microsoft and then do an FTP where you download the Microsoft software over to your server. I'm just using Microsoft as an example, but there's all kinds of software that you might not just come from your laptop, but it might come from the vendor. And you're just loading. It's kind of like when you set up your own laptop for the first day you have it. You're going out and downloading this thing and that thing, the other thing. You're getting it set up. Same thing.
Well, let's take the example of big data, because that's the one I think that fascinates me. And we talk to a lot of scientists here from University of Hawaii, and they all have access to big data. They all need big data to do their research projects. I mean, I haven't met one yet that doesn't have big data behind it. It's the main engine of science, it seems like these days. So they don't need to have a computer building. They don't need to have big servers under their desks. They can spin one up on the web this way. They can program it as they will, and they can use it. And I'm going specifically to an example. They can use it for big data, and big data means, depending what field you're in, it means a lot of fields, a lot of storage, a lot of search capacity, all that.
A lot of number crunching, a lot of CPU.
Yes, right. I mean, programs that takes days or weeks to run, that kind of thing.
So universities still have their high-performance computing clusters. There's some very advanced environments. They're still spending a lot of money on that. But for instance, with our bare metal, we have clients that will come in and I always use the term spin up. I'll say provision. They'll self-provision 10 of our bare metal servers and create a high-performance computing cluster. They can use one out of the 10, let's say, as the controller, and you load high-performance computing software on that controller, and then the other 9 could be your high-performance computing cluster. And then we have 10 gigabit per second networking, which is very fast. There's things like InfiniBand, there's other technologies you can use. But the 10 gigabits per second for most of our clients, the types of clients we're working with, we're getting the cost down on this networking by so much that it's just a fraction of what InfiniBand would cost. So we're getting folks coming to us, building out these high-performance computing clusters on demand using our bare metal. The other thing they can do with our bare metal servers, which is very interesting, is they could create, let's say you take those 10 servers that you created in 5-10 minutes. Now you've got this cluster of bare metal servers, nothing loaded on it, no hypervisor. You could actually bring in VMware. You could bring in the quote-unquote the enemy and load it, right?
Yeah.
And run cloud inside a cloud.
Sure.
And that is what gets everybody I talk to that's not really, even people that use the cloud, they stop. VCs, all these folks, they stop and look at us. Cloud inside a cloud? Explain that to me. Well, my point is what if you're going to take a cluster of 10 servers in your data center in a rack, and you're going to load VMware on these 10 bare metal servers, what's the difference from going in 5 minutes having 10 up with us and loading VMware?
Well, I'm very impressed with the possibility. The University of Hawaii just spent, I want to say $35 million, something like that, maybe $40 million, on a building and a set of computers that would be, a high-performance computer center for some of the departments, many of the departments there. And likewise, I don't know if you know, but we have a high-performance computer center in Maui that was built for defense purposes, but it's also for academic purposes. But you're saying that using this kind of technology, you can build it from Starbucks with a credit card and pay, and if I'm looking at the bare metal price of, say, $100 and change per server, and if you have one controller and 9 data servers, then that's $1,000 a month. That's a lot cheaper than building a high-performance computer center.
Well, our most expensive server is about $1,600, $1,700 a month, so it really does depend on what you're trying to do. But I don't want to take away from what they're building at these universities, because they could be running InfiniBand, they could be doing some supercomputer work. They also, the people on campus could have fiber to their building, even to their desktop. They could be achieving rates of throughput to that network. that make things possible you can't do with the cloud. And the big problem with the cloud is until we all have gigabit to our buildings, the last mile, you know, that's why I think Google is doing something in St. Louis, Missouri, or Kansas City, I think it is, where they're doing an experiment in Palo Alto, California, I think too, where they're running gigabit to the home. Until we start getting those kinds of throughputs everywhere off the internet, it's going to make a lot of these things difficult, because frankly, we had somebody just recently send us 40 terabytes of storage of content from Australia. And you know how they send it? FedEx is still the fastest, cheapest way to move data across the planet.
Isn't that true? I agree absolutely. I mean, for example, ThinkTech Hawaii submits movies to Oceanic Time Warner Cable on a weekly basis, but you have to actually physically deliver the movie. It's on the other side of the island. It's a bit of a drive. You have to, you know, physically deliver a drive to them. And so every week I say to myself, you know, there must be a better way to do this. And we're talking only about a few you know, gigabytes. It's not a lot, but no one feels comfortable in moving it around on the existing system. I told you also that I get 100 megabits here at ThinkTech for our broadcast. This is being broadcast on a 100 megabit connection. Yeah. But gee whiz, just suppose, you know, we had gigabit connections, and what did you say before, 10 gigabits or more?
We're running 10 gigabits and even 40 gigabits on our network. We also have customers doing private clouds where they're doing up to 120 gigabits by connecting together multiple 40 gigabit links. But that's internally in our network. The problem everyone faces is, I mean, that's one of the challenges of us trying to get a customer to come over from, like, let's say, an Amazon. They might like something that we have, but they'll say to us, you know how long it's going to take to move the data? I mean, Amazon does offer a service, we do too, called import-export, where you can send them a big storage server and say, load everything off your cloud into my storage server off your network, and then ship it to me. That's what's nice about what the business we're in, frankly, is once a customer gets in with us, you know, we're pretty sticky because it's hard to move things around. So it's a real problem on the internet. So there's wonderful things about the cloud, but for certain scenarios, there's limitations.
Yeah.
So
it's all going in a certain direction, though, Bruce, isn't it? I mean, for example, going back to my academic data crunching thing with big data, you know, all of these scientists are collaborating with other scientists around the world. Can you imagine how much more efficient they would be if there was a cloud that would enable all of them to connect to the same place, all of them to do and look at the data crunching that any of them are doing? I mean, it would change the way science works.
Well, and even 10 gigabits per second is fast enough. I mean,
okay.
You know, what we need is 10 or 40 gigabits per second, because some of these folks doing the big data, the amount of data they're moving, even at a gigabit per second out of our data center to another data center that has a gigabit, it can still be prohibitive in how long it takes to move the hundreds of terabytes, even petabytes of data. So it is a challenge.
So what happens? I mean, how do you see this progressing? This is part of, you know, this is an inch away from your core business. All this about, you know, data speeds. So how do you see that progressing? I mean, is it possible that with the same physical infrastructure you can get better speeds? Or is it a matter of getting Comcast and Time Warner and who else lays the cables to put new infrastructure in? I mean, how are we going to get where we need to go?
It is that. I mean, that's what Google's doing. They're digging up trenches and they're running it to their home.
Yeah.
And it has to be via fiber to get the distances they need.
Yeah.
So, but even going across the ocean, you know, there's some multiplexing technology that allows them to get more out of a strand of fiber. So I think that will continue to advance and get more out of the fibers running under the oceans. But it's a big challenge. Satellites are helping some, but there's still issues with that. It becomes a physical challenge. I mean, we're even still facing the speed of light challenge. That's why it's important to have multiple locations around the world, because we might have a customer, we're about to put up Sydney, Australia, and Singapore locations to go with our East Coast, West Coast locations, and we want to have a European one pretty soon. Why do all that? Well, the fact is that a website always loads faster when you're close to it, or a database is easier to access when you're close to it. So that's something that nobody can get around until they figure out how to go faster than the speed of light. There's just these limitations.
Have we ever done that? No. Just wondering.
Yeah, I wish. So one thing about big data that's nice, people can come and run big data processes on our platform and never have to leave the network. What they'll do is they'll get the results from crunching the numbers, and then they'll download those results. So there are a lot of applications where they can find ways to keep it on our network and not have to take a lot of content off the network. It'll just go in between our cloud storage and our servers. But the universities, they build their own networks. They can get a lot of traffic between the offices, the buildings, where the labs, to the data center area. There's still a use for that, even in this modern cloud age. I don't want to. I would be misleading people if I tried to make them think that the cloud was everything to everybody. But what it has done, it's lowered the barrier to entry for companies that want to get into business. It's reduced time to market substantially. It's made it much easier to experiment. I mean, even in the days when I was at Foundry Networks selling switches and routers, and I knew a company was putting up a location in Singapore, they would have to sign multi-year or at least one-year deals for bandwidth, for data center space. They'd have to buy servers from Dell or HP or whomever, and ship it out. And what if the experiment turned out bad? They say to their boss, "Sorry about that, boss. You ship all the stuff back. You have to pay out the contracts." It's a disaster. With cloud, now there's so much agility. You can try something. If it doesn't work, can it? Cancel it. You paid by the hour. Big deal. So the time to market, the barriers to entry, it's changed everything as far as business models. And frankly, it's good for startups. It's made it really great for people that want to get going and build a web scale app and experiment with it and do it on the cheap.
Yeah. So I mean, how it's like, how long are you committed? I mean, suppose I decide I gotta throw this over the side. It's not working. I'm going to have to try something else to achieve my business plan. What do I do? Just terminate the connection and say farewell and pay through the end of the day or the week or the month? Is it that easy?
No, you just go into our system, delete the server, and we charge by the hour.
So you don't hold me to any period of time after that.
No contracts, no commitments.
Gee whiz, that's incredible. So I mean, well, yes, as you said, I mean, it makes entrepreneurship in this space easier, cheaper, more nimble. But what about in the larger sense? I mean, if you can speculate a little, Bruce. I mean, how is this new server availability, new flexibility going to change the way, if I may, the way the world works? How do you see it going forward?
I would just say it just is going to continue to drive rates of innovation, at a pace that we have not seen before 2008, when this all started to become possible to manage data centers remotely. That's really what it comes down to is that, and you'll see more and more enterprises. I mean, right now, there's about 2.7 trillion, debatable the number, but it's close to that, of IT spend worldwide. There's about 10 to 15 billion in public cloud, which is our primary business right now. I mean, it's, excuse the term, it's mice compared to what's really going on out there. So 80% of all dedicated servers, or servers sold today, are going towards to enterprises, not to a cloud environment. So there's still a lot, like these universities are building their networks and their data center environments. There's still a lot of stuff going on outside the cloud. So I would say that over time, you're going to see more and more of this get into a cloud environment where a company like ours is managing it for you. But one thing that we do to capture all of that business outside of the area where public cloud plays is because we built our technology top to bottom. And that means the software-defined networking, all the provisioning, the inventory, ticketing, billing, all the software. So some of your viewers might be familiar with OpenStack, which is an open source platform for cloud. OpenStack is not a product. It's a open source, the largest open source project ever attempted. 8,000 developers contributed. Some people would argue there's a lot of bloated code in there, and they can be quite unstable. There's a lot of good things they're doing, but at the same time, even if you did want to use all OpenStack for your cloud, it would only make up about 50% of the code that you would need in order to have a full public cloud. You could do a small private cloud inside your enterprise, but if you wanted to have a customer go put in a credit card and, quote unquote, spin up a server and be able to open a ticket with a support team in a full public cloud environment, about 50% of it is going to be proprietary tools or third-party applications, and then you have to make work with the OpenStack. So the OpenStack consultancy business is a very big business because not many companies can do it on their own. So it's a big deal that we built basically an OpenStack plus the other 50%, all our own. So we don't use any third-party application. So we can license it. So that means if an enterprise or these universities you're talking about, so come one, come all, we're looking for partners, we're about to do an announcement with a very large multinational corporation that will announce a software agreement where we're going to bundle our software with their hardware and allow them to sell it in a cloud environment or allow their customers to consume their hardware as a service without actually having to buy the box from them. But what I'm getting at is, let's say a university, in fact, we're talking to a couple. They ran our NephoScale cloud stack, software stack that powers our cloud. They can run it. We can have it set up within 48 hours once the equipment's up and give them the full cloud environment. So virtual servers, dedicated servers, API, triple replicated cloud storage. We do based on OpenStack Swift. They can have all of this together and have a true cloud environment within 48 hours of telling us the equipment's up. And then they can take that and they can integrate it with our portal. We can do it for them. Where when they go in and put a credit card into our system, they will pay to configure servers in our locations in the public cloud. But they will also see all of their equipment, their on-site equipment. And they'll be able to provision that through a portal or our API. And of course, we would not bill them for that because they own that equipment. And they would pay us a software licensing fee on a per processor basis for all the equipment they're running our software on. But now they would have what's called a hybrid cloud environment. So we have two things we're trademarking right now or hybrid compute. So hybrid compute is the virtual and the dedicated together, the best of both worlds for computing. The hybrid cloud is the best of both worlds of being able to join your on-site and your off-site cloud setups. So we go in and cloudify your environment and then seamlessly integrate it. Why would you want to do that? Well, let's say you have a list of custom server images or scripts or things you have in our system that are in libraries that you can choose from that you've built that save you time. Now you can use common libraries across both your on-site and off-site locations. So you don't have all these clouds you're trying to manage. You just have one. And that's pretty slick. You can even use our networking to tie the networks together in a very unique way. And then with our bare metal servers, you can either be running VMware or some other type of cloud within our cloud. And again, this gets into head-spinning stuff, where you start to realize that almost anything is possible the way we built this thing. But VMware doesn't want you to know that. Microsoft, they're probably listening right now. They're going to be scouring our website tomorrow and wanting to do bad things to us. But
I hope we bring them down for a look.
Yeah, we're just a little bad. We have no chance. So, but we are, there's certain parties. One of the large Big Five in consulting firms, very well-known company, this manufacturing company, one of the largest data center operators in the world is talking to us. So they're complaining that they think cloud is not doing what they expected, that the big companies have come in and they're maintaining too high margins and they're creating these boxes that people need to fit in. And somebody like us comes along and says, we'll cut the cost significantly and we will allow you to run virtually anything you want, being able to use the combination of virtual and dedicated servers. And you're not limited to any one company.
Amazon's not doing that. Amazon's not offering that service.
That's exactly right.
So what about, so your secret sauce then is the software, this cloud stack software you mentioned, another software that helps to use the physical boxes in a special way. Is that what
so we built our own stack we call NephoScale. We implement pieces of OpenStack as we see necessary, but it's not like we built on OpenStack and then we pull in proprietary items that we think are necessary to make it work. We build our own platform from the ground up and then we pull in pieces of OpenStack as we see fit. And we think it's more like the Google method, where they like to build purposely built tightly integrated software stacks that they know are fast and manageable and stable. And if they modify them, they don't break. And that's what we've built. We have something that we know works and does not have stability issues. The other thing we did is we built in this thing, this ability we call hardware asset ingestion. So it's the ability to take in anybody's equipment. So if anybody's at a university or anything else, an enterprise watching this, and you know you have EMC or NetApp or Hitachi Sans, you've got all these different types of equipment, any brand of server,
They can all work together.
we can ingest the information, build it into the mainline code very quickly, and allow basically adds to the plug-and-play list. And there's no other cloud company we know of that's doing this.
Bruce Templeton, the CEO of NephoScale. And yes, I have a little headache, but I think it'll go away. I would like to talk to you again about this in a few months or a year and see what kind of progress you made, how you've gotten into places in the market where you're not now, and see how the whole thing has changed, because it does feel disruptive and it is changing. This has been ThinkTech Talks. We're talking about business intelligence and the emergence of the base metal cloud system with Bruce Pendleton. Thank you so much, Bruce.
Thank you. It's my pleasure, Jay. Have a great day.
Aloha.
Bye-bye.
Well, you can go back to ibuprofen now.
So I hope you didn't